Okay, today we're going to talk about inverse trig functions. And we're going to cover the Integrated Algebra Standard AA43, which is determine the measure of an angle given the length of any two sides. Okay, and yesterday we talked about how do we find the length of the two sides given the angle. Now we're reversing that. So we're going to use the functions inverse sine, inverse cosine, and inverse tan. Okay, so let's talk about what the inverse functions do. And the best way to talk about that is to first talk about what the trig functions do. So if I take sine of an angle, I get back a ratio of opposite over hypotenuse. If I take cosine of an angle, I get back a ratio. Okay, and if I take tan of an angle, I get back a ratio of opposite to adjacent. So this relationship is what I want to point out. You put in an angle into the sine, cosine, and tan function, and what you get back is a ratio. Okay, the inverse trig functions do the opposite. You put in the ratio, and you get back the angle. So, for instance, sine inverse, you put in the ratio of the opposite side to the hypotenuse, and it gets you back the angle. If you have the adjacent side and the hypotenuse, then you use the inverse cosine to get back the angle. And finally, if you have inverse tan, you put the ratio of the opposite side to the adjacent side inside this function, and you get the angle back. Now notice that the difference between the notation for the regular tan function and the inverse tan function is this little tiny one that's in, or negative one that's in the exponent position. So we read this as tan inverse and sine inverse and cosine inverse, or inverse cosine. We can say it that way too. Okay, so let's talk about how we use it. First of all, on a calculator, inverse tan is above, so this right here is the tan button. Inverse tan is above that. All the inverse trig functions are above the regular trig function. So here's sine, cosine, and tan, and the inverse are, you have to hit the second key and you can get the inverse. So let's say that I have the ratio here. So for angle A, I know that the tan ratio is opposite over adjacent. Let's say that I know that this is 4 and this is 3. Okay, or, well, let's say it's 4 and 3, but I don't know what angle A is. What the inverse tan does is, so what I know is that tan of A is equal to 4 over 3. Well, I can take that ratio and I can put it inside the inverse tan function, and what I get back out is 53.13. So I rounded it to the nearest hundredth, and that tells me that angle A, the measure of angle A, is equal to 53.13 degrees. Okay, again, you want to make sure that your calculator is in degree mode because we are working with degree here. Now, in order to do that, let's just review real quick. You have to go to mode, and then you arrow down to radian, and then you go over to the right 1 to get degree, and you press enter, and then second quit gets you back to the home screen. So just make sure you are in degree mode. Otherwise, you would have gotten a radian, and since you haven't seen that before, then it's going to be a little confusing to you. Okay, so that's how you get, that's what the inverse tan function does. Now, the inverse cosine, let's say that this would be a 3, 4, 5 right triangle. So let's say that instead of knowing the tan, you knew the cosine, right? So let's say that you knew that cosine of angle A was the adjacent, which is 3, over the hypotenuse. Okay, then if you did cosine inverse of the ratio, which is 3 over 5, you would still get back 53.13. Okay, and you can try this on your calculator if you have it. If you don't have a TI-84 at home, you can always, you could always find an online calculator in order to help you perform the inverse trig functions. Just search online scientific calculator. And every once in a while, instead of inverse tan, some calculators will call this arc tan. Okay, and that's the same thing. Okay, so let's figure out how this is going to help us. Let's say that we have a right triangle, ABC, and we know 2 side lengths, but we don't know the third side length, and we don't know any of the angles inside except the 90-degree angle. We don't know any of the acute angles. Well, first of all, we can always get this side because that's going to be let's call that A, because that's across from angle A. So we know that A is equal to the square root of 6 squared minus 3 squared. Okay, that's the square root of 18 minus 9, 36, whoops. It's 36 minus 9, which is, 36 minus 9 is 27. Okay, so it's the square root of 27, which we could rewrite, if I want to simplify that, that's 9 and 3. That comes out as a coefficient of 3 root 3. So A would be 3 root 3. Okay, and that's an exact figure, right? 3 times the square root of 3 is exact. So I can use that in further calculations and not be concerned about any rounding errors in those calculations. Okay, so let's say that I want to find angle A. All right, there's lots of different ways that I could do this. Knowing now all three sides of the triangle, knowing that 3 root 3 is not an estimated answer, it's the exact answer for that final side. Okay, there's many different things I could set up. If I wanted to use 3 and 3 root 3, according to A, that is the opposite and the adjacent side, and the trig ratio that's set up for opposite adjacent is tan. So what I could use is, I could say the tan inverse of the opposite, which is 3 root 3 over 3, that's going to be equal to A. Okay, that's one thing I could do. I could also say that I could also use the 3 and the 6. Now that's the adjacent and the hypotenuse. So I could say cosine inverse of 3 over 6 is equal to A. And finally, I could use the sine inverse of 3 root 3 over 6, and that would also get me A. Now these are all going to be the same thing. So try these out on your calculator. You should get the same answer. Okay, now I did this on the calculator, and I'm showing you the keystrokes. Okay, so if I wanted to do the inverse cosine, I would do second cosine, because that would get me the inverse cosine. Alpha y equals gets me the fraction. Okay, and enter, that's the first option in the fraction menu. 3, and then I arrow down to put the denominator of 6 in. I close my parenthesis and I press enter. That gets me 60, so it's 60 degrees. Now I did the same thing, just to check, I did the same thing with tangent, the inverse tan and the inverse sine, and you can see that in the second picture here. And they all get me 60, just like I said. So you only need to use one, but I wanted to... Okay, so it all gets the same thing. So you can choose whichever, function that you have. Now let's say that 3 root radical 3 wasn't an exact answer. You might want to use something, you would want to use the ones that were given to you in order to find it. But since 3 radical 3 is exact, I could have used any of these ones. Okay, let's try a different problem here. So let's say that I had a right triangle. And this right triangle has, so let's see, I have a right triangle here. So I'll put a little square in here to indicate that's a right triangle. And say A, B, and C. So C has to be the right angle here because it's specified in the problem. So AC is 4, BC is 9, and we are looking for the measurement of A right here. Now, since I'm given, I could find the hypotenuse if I wanted to using the Pythagorean theorem, but they're only looking for the measurement of A. So I might as well just do what they're asking me to do. So according to A, 4 is the adjacent side, and 9 is the opposite side. Okay, so I only need to use the trig ratio, the inverse trig ratio that deals with adjacent and opposite, which is tan. So let's use the inverse tan of, and it's opposite over adjacent, so it's 9 over 4, and that should be equal to angle A. Okay, and I calculated that on my calculator, and I get this right here. So let's round to the nearest hundredth. Okay, there's a 2 here, so we're going to keep 96 the way that it is. So it's 23.96. And we know the units here. We're talking about degrees. Okay, so that's the answer to this question. All right, let's try a word problem here. Okay, find to the nearest degree the measure of an angle of elevation of a vertical pole when it is 6.5 meters high and casts a shadow 8.3 meters long. So you have this pole here, and we know it's 6.5 meters tall, and it casts this shadow that is 8.3 meters long. Okay, and what we're looking for is the angle of elevation. Okay, so right here is the angle of elevation. Okay, so let's think of this like a right triangle. Okay, it's a vertical pole, so it's tangent to, or it's perpendicular to the ground, the horizontal ground. So I'm looking for this angle right here. Let's call this angle B. And the things that I've been given are, again, I'm given the opposite and the adjacent angle. So right here, I can again use the inverse tan, and the opposite is 6.5, and the adjacent is 8.3. Okay, let's go ahead and calculate that. Okay, so according to my calculations, the angle would be 38.07 degrees. Okay, and that's how I would do that. Now, we use a lot of inverse tan, but remember, depending on what you've been given, you can use the inverse sine and the inverse cosine as well. Okay, let's try one more problem here. So let's say that a ladder, 25 feet long, leans against a building and reaches a point 23.5 feet above the ground. And we want to find the angle that the ladder makes with the ground. Okay, so it's always important to draw a picture. And this picture was in our book, so I just pulled it out from the book. So here we have the ladder going up the building, and it makes, so it reaches a height of 23.5 feet from the bottom of the building to where it hits, and the ladder is 25 feet long. And what we're looking for is the angle that the ladder makes with the ground. So in our picture, we're looking for angle A. Now, angle A, so what we're given is that the length of the segment opposite of A is 23.5. So we have the opposite side length, and we also have the hypotenuse. Okay, and if we remember, the sine ratio deals with opposite and hypotenuse. So what we want to do is we want to put into the inverse sine, we want to put the opposite, which is 23.5, over the hypotenuse, which is 25, and calculate that. Now when we do that, we get an angle of 70.05, right? So that's a 1 there, so that remains a 5, and that's in feet. Oh, nope, that's not in feet, I'm sorry. This is an angle, so it is in degrees, okay? And so that answers that question. All right, so what you learned today is you learned how to find an angle inside of a triangle. By the way, I could always find this third angle by adding 90 and 70.5 together, or 0.05 together, and subtracting whatever I get from 180, okay, to get that third angle. So what you learned today is you were given side length of a triangle, and you found the angles inside, and that is exactly what the integrated algebra standard said that you were supposed to do. So determine the angle given the lengths of a side inside of a right triangle.